In this video, we're going to look at how to figure out the equation of a line. So in this case, we're going to look at how to figure that out given one point and the slope. So let's do that by looking at one particular example. So in my example, I want to know the equation of a line that passes through 1, 3 with a slope of 4. So that means if we were to graph this line, we would have it passing through a point 1, 3, and it would have a slope of 4. I'm not going to draw it because I actually don't know the y-intercept yet, but we can figure that out. How will we do that? Well, there is an equation, a general equation for lines, and that is that y is equal to mx plus b. What does that mean? Well, m, if we see the equation of a line in this form, m tells us the slope or the gradient, b tells us the y-intercept, and the y-intercept is where our line crosses our y-axis. X and y are just any point on the line. So for example, we have one example of one point on the line, and that's 1, 3. But there are infinitely many points on our line. This is just one example of one point, one x and one y that can be on our line. So let's write that down, that we know that that's one x value and that's one y value on our line. All right, so now we need to figure out what b is, or y-intercept, in order to figure out the equation of our line. So we can plug into the formula that we have, the general form, y equals mx plus b. Y, since we have 1 point, 1, 3, we can plug in that y is 3, and we can see that here. And we can plug in that x is 1, and that comes from our point as well. So 3 equals m is our slope, which is 4, times x plus b, which we don't know yet. But we can simplify this and solve for b. And we get that 3 is equal to 4 plus b. Now we can isolate our b by subtracting from both sides. And we get that b is equal to -1. Once we have that b is equal to -1, we now have enough information for our equation. We have our slope and we have our y-intercept. So our equation is y equals 4x minus 1. We leave x as x and y as y because remember that x and y represent every point on our line, and there are infinitely many points on our line. Okay, great. So how about when we don't have our slope given? Well, if we have 2 points, we can figure out a slope. So let's do that. So in this example, we're going to be given 2 points. One is 5, 4, and the other point, let's say, is 1, -1. So let's just take a quick look at what that would look like. 1, 2, 3, 4, 5, 1, 2, 3, 4. So one point would be over here somewhere, and 1, -1. The other would be right here. So we are looking for the equation of that line. Now, we could take a guess at what it is, but that's not good enough because that sketch is terrible. Very, very, very quickly drawn. So how do we figure out the equation of this line? First, we need to figure out the slope. So slope, or slope equation, you may recall, is y2 minus y1 over x2 minus x1. We first need to figure out our slope. So let's call this x2, y2, x1, y1. So our slope would be equal to 4 minus -1 over 5 minus 1, which is 5 over 4. All right, great. Once we figure out our slope, it's starting to look like the previous problem. We just need to pick 1 point and 1 point only, and it doesn't matter which point we choose. I prefer to work with positive numbers, so I'm going to pick 5, 4. But if you like, you can try the other point as well. So I'm going to do the exact same thing we did in our previous example by using the y equals mx plus b formula. And I'm going to plug in our point and plug in our slope. So y is 4 equals m, which is 5 over 4. We just figured that out. Or x is 5 plus b. And now we can simplify that and solve for b. 4 is equal to 25 over 4 plus b. And we can now subtract 25 over 4 from both sides, and we figure out that b is equal to negative 9. Well, let's erase that and fix it. Negative 9 over 4. So there we go. All right, so now we're almost there. Now we see that we have our slope, which is 5 over 4. So y is equal to 5 over 4x minus 9 over 4, which is slightly less than 2. So if we had to take a guess, it looks like that was at 2, but it's not. It's actually negative 9 over 4. That's our y-intercept. So that's a kind of a good lesson that it's not a great idea to just sketch the line and look at where you think the y-intercept is. You should really work it out. Okay, let's look at one more thing and then we'll be done. Okay, so you know now how to figure out the equation of lines that are slanted, that have a slope. But how about lines that are either horizontal with a slope of 0 or vertical with an undefined slope? Let's take a look. First, at our horizontal lines. All right, so now I'm drawing a line at y equals, let's not tell you what that is. All right, so there is a line that's crossing the y-axis at 3. So y, we know our b is 3, but the slope of that line is 0. So technically I could say that y is equal to 0x plus 3. However, I really don't have to say 0x, because 0x, as you know, anything times 0 is just 0. So that equation should actually be y equals 3. Any horizontal line has equation y equals c, where c is the y-intercept. So for example, again, just to make sure you got this, if I drew a line here when the y-intercept is negative 1, our equation would be y equals negative 1. So again, any horizontal line has the equation y equals whatever the y-intercept is. Now, another way to look at that is just to think about the fact that the coordinates everywhere along that line is negative 1, the y-coordinate, that is. It doesn't matter what the x-coordinate is, but everywhere along that line, y is negative 1. So it's the perfect description of that line. In the same way, if we were to draw a vertical line, let's put the vertical line here at 2. Well, everywhere on this line, x is always the same value. Everywhere on this line, x will always be 2. So the equation of that line is x equals 2. So any vertical line has equation x equals some number, let's call it k, where k is the x-intercept. So again, horizontal lines have equation y equals some number, where vertical lines have equation x equals some number.